Assalamu alaikum wa rahmatullah wa barakatuh. Today we will continue with the series of recordings of M256 software development with Java. Our unit to cover today is Unit 11, Human-Computer Interaction. Let us start with the unit aims. In this unit, we will describe the importance of HCI, why HCI is important, and why we need to understand ways of building good human-computer interaction. We'll have a look at the history development of HCI, which will be further analyzed in Unit 12. We will also introduce the basic concepts of HCI. We will cover metaphors, direct manipulation, and ideas of design principles. Some common graphical user interface components will also be discussed, considering their functionality and their relationship with design ideas. Human-computer interaction, HCI, is the study of how computers and people work together, how computers and people interact. So it has two sides: the scientific study of how human and computer interact, and the practical business of designing the user interface. The usability is one very important concept when it comes to human-computer interaction. It's defined as how easy and quickly a product enables users to achieve their goals. We build a user interface that will ease using the system, make it faster and safer for the users to use the system. Easy to learn and enjoyable to learn. If we can have all these features in the user interface, then we can say that we have achieved the quality of usability. Now, why human-computer interaction is important? Because when you have a good user interface built on the principles of a human-computer interaction, then the safety of the user will be increased. Also, when the people like your interface, they will like the system, and it will increase the market share for your application or your system. It allows things to be easier and hard tasks to be achieved and possible. It will be easy to train people to use the interface and will be effective when the system is used. We facilitate extraordinary HCIs, and what we mean with extraordinary is special human-computer interaction user interfaces. Special from the side that it will be used by special needs people who cannot possibly use their hands, or people who are blind, or any type of disability. So the human-computer interaction principles can be used to build a good user interface that will help these people to use the computers. If the system is easy to use, then performing tasks on that system will be easier and faster and that will improve very much the productivity users. Now we go with details with the safety issue of human-computer interaction. We know that many systems are critical systems. And what do we mean by critical systems? Means systems that can affect human life or can cause a big damage if it's not running the right way. Something like the systems found in the ambulances, aerospace, nuclear stations, medical centers. All these are very important to be built the right way and to ensure the safety of the users who are using them or benefiting from them. And as you can see in this study, there's about 7% of 1,000 computer-related deaths related to a fault in the software and hardware, where the other more than 90% is because of human factors and the human-computer interaction. Means in most of the cases, problems with the user interface not being built on a safety basis can cause big problems and serious problems with the safety of the users of the systems. Market share, when the user interface is built the right way, it will attract more people to use it. And when the people like the interface, they will like the system. And we all know that a system or a site like Google has many fans and users, people who likes it and find it very easy to use, very interesting, very enjoyable to use. So you'll find that such kind of interface will attract people to the system and will raise the market share for this particular application. Now, another site which is also very famous, Altavista search page. If you compare between it and Google, you will find that the Altavista search page is very crowded with a lot of components in the interface, making it hard for users to find things that they're looking at. Where Google, as you'll find in the next slide, will come very simple and user can easily find whatever they are looking in the site. Google decided that no advertisements will be on the in the main page of the search engine. It will be based on the content of the user search. And that decision was very crucial and proved that Google has taken the right decision when it follows this kind of design. Another example of success is iPod, as you can see in this slide. In this application, the user interface was designed with a great attention to usability. So the control is very simple. The interface gives a very good feedback at all times, and the users will consider all these features and prefer to use it over any other related or application that does the same kind of functionality. The user interface can be made easily when it is consistent. Means common features in different interfaces can be used, so the user will have the same interface when moving from one interface to another, or the same components, the same mechanisms, and that is a good feature and makes it very easy for users to use new interfaces. Now in the web, you find that it's easy to use the applications the web-based applications because they always behave almost the same way. Same as virtual reality. In virtual reality, ways of interaction are very much like the natural ways of interaction. You deal with the objects in virtual reality the same as you deal with the objects in the real life. And you have a sense of direct physical presence. So because you, as a user, deal with the real life objects every day, you find it quite easy to deal with the objects in the virtual reality the same way that you interact with objects in your real life. In this slide are examples of virtual reality systems normally used in medical schools and in many cases used for training people to drive, for example, or do some complicated systems. So if it's hard or very expensive to have these systems available for users to use and train on, we can produce them in virtual reality in a much less expensive way. Now, a very important feature of human-computer interaction is its support for extraordinary human-computer interaction. What we call it extraordinary HCI is a term used to describe a human-computer interaction in situations where the user has special needs. So when the people are having and the users are having special needs, they will not be able to use the normal interface. And the flexibility with the human-computer interaction may help us to provide them with specialized user interfaces, considering their special need. And very famous example of the scientist Steve Hawking, who has special interfaces with the computers that consider his situation. Also, human-computer interaction can be used to train people and cut the cost of training. So we can build systems that simulate real-life systems and use these systems to train people as the real-life systems. Of course, if we consider all the good principles of user interface design, the using of the system will be quite easy, and training people to use it will be fast and less expensive. One very important feature that we mentioned earlier is the consistency in the interface. If things are done the same way in different applications, then you don't have to spend a lot of time training people to use one application and another application. With consistency of the interface, users will less likely make errors as they have this kind of functionality done in other applications or in other parts of the same applications the same way. People will be able to do things faster and raise their productivity because the user interface is helping them to perform tasks in much faster way. So productivity is very important result of having very good human-computer interaction design. We can achieve high productivity by allowing users to do their tasks in a very fast way, and that will be achieved by providing them with a user interface that's easy to use and consistent. When the user interface is usable, easy to use and consistent, the users can perform their tasks very fast and achieve high productivity in performing their tasks. A special type of systems that needs good user interfaces is what we call a socio-technical system. This system comprising both human and technical elements. It can be one user and one machine, or possibly thousands of users and thousands of connected machines. Now, when human and machines interact, we called the interface of this interaction user interface. Now, after all these discussions, we can come out with a definition of the user interface of a system. There are the features of the system the user can use to communicate or control the system. It also includes the features that may influence the user to communicate with the system. In this definition, we have three aspects: the hardware, the visual elements, and the interaction design. If you consider the hardware as part of the user interface, we have elements that we use to communicate, to interact with the computer as hardware components, such as the mouse, the keyboard, screen, the microphone, the speaker. All these are hardware components in the interface. On your screen, you will see visual elements of user interface. We call them widgets, which are visual elements in the graphical user interface, such as buttons, menus, lists, text field, text areas, and so on. Now, very important say that we always have to remember and consider: to most users, the interface is the system. This means that if the user likes the interface, then he will like the system. And if he hates the interface, he will hate the system. So if you want your system to have popularity among the users, to succeed, then you have to be sure that they will like your interface. And they will like your interface when you consider all the good principles of a human-computer interaction when you're designing that interface. So the challenge you are facing is to design a user interface that enables appropriate interaction between the user and the system. Now, the last part of building the user interface, or the last aspect of building the user interface, is the interaction design. This aspect includes three main points: how tasks are divided up between the system and the user. This means what the system will do and what the user will do when we divide the task or the tasks. And also to what extent the user controls or the system controls what happens next. So is it the system decision or the user decision to decide what's coming next? Timing is very important, and ordering of dialogues is very important also. This also must be designed to decide how long tasks will be taken to be performed and in what order. Now, interaction design refers to the design of any aspect of the system that affect the quality of the user interaction, and it will be built correctly if we consider the three issues shown on this slide. Now we cover the most famous interface styles. The first is command line user interface. This is an old style of user interface used in the MS-DOS, where everything in the interaction is based on commands. So user need to write commands to perform any task on the system. A very much enjoyable and easy to use user interface is the graphical user interface. In this kind of interface, which is the common one in Windows and in the browser that we are using nowadays, you have graphics, you have menus, buttons, windows that can open and close, and you can easily select and move from one widget to another. It may do or does the same thing as the command line interface, but it will do it in a very much faster way without a need for the user to memorize any command. Another style, which is also a famous style of user interface, is the menus or the menu interface. This interface is common in the automatic teller machines, ATMs, where every screen will give you a menu of choices and you have to select one of these choices. When you select a choice, it will show you another menu with more choices until you finish your task. Very importantly, we need to remember that to some users the system is the interface. So we normally consider the term user-centered design. Means the user is my center attention when I design the user interface. I need to do users' need analysis to understand my users' needs, my users' expectations, my users' limitations, and build my interface based on these facts. And as you can see, you may consider different kind of aspects. How do people learn? How do people think? How do people feel about the interface? What language is the suitable language to be used? Now, how can we build a good user interface? There are some guidelines and golden principles that we follow to build a user or a good user interface. One of the guides that I have mentioned earlier in this presentation is consistent. So if you build a consistent interface, then you ensure that users will be able to use that interface easily. There are more principles and guidelines that we will cover in chapter 12 regarding of how to build a good user interface. But here we will ensure one important point, that a good developer will understand the users and do a kind of needs analysis to find out what the users want and what is the right interface for the right users. Some of the questions that we may ask is, for example, what is the typical user like? Okay, different people will like different user interfaces. You may consider the age. Citizen people will like different interfaces from children. Maybe women will like different interface from men, and so on. Another question that we want to ask is, what does the user want to do? Is it a home application? Or is it a professional application? Is it a complicated task or it's simple task? Now, we also need to consider the environment and answer the question, where will the system be used? Is it going to be used at home or in some professional place or in some noisy place? All this must be considered to be able to build the right interface for the right users. We continue with the design principles to find psychologically what are the things that we need to consider and what are the design principles that we need to follow to be able to build a good user interface. We say that the user interface should have good visibility, good affordance, and good feedback. In the following slides, we will discuss what do we mean by these three principles. First, we start with the visibility, and we define it as the extent to which something purpose is apparent. That is, how clear it is what the thing is for. So if you look at the object and you know what for is it there, then you can say that this object has a high visibility. A very good technique to help us building a visible component is to label it. So if you give it a clear label and that label tells us what for this component or this widget is, then you will increase the visibility for that particular component. Or positioning it. If you put it in the right position, then the positioning of the component will tell us what for that object for. Visibility also include being able to see the object and observe it. Simply in this slide, the button is different from the background, so we can easily see the button, but it does not have high visibility because the label is not clear. It says press me. So what for and what result I will get by pressing this button is not clear, which make the overall visibility low for this component. If this label was if this button was labeled with the right label, then I will be able to say that it has a high visibility. For example, if I say submit, then I know that when I click this button, I will be submitting some information, and that's what we mean by visibility. How to use the object or the widget or the component is what we call affordance. So if the appearance of the object or the widget tell me how to use it, then I will say that this object is having high affordance. You want not to confuse affordance with visibility, because affordance is concerned with what to do to get the component work. Do I need to click it or drag it or read it or anything else? While visibility is deciding is what for this widget or this object is in the interface form. In the real life, you find that the handle of the door tells me how to use it. Or for example, in the lift, you find that the buttons are coming out comparing to the service level, which tells me that if I want to use this button, I have to press it and send it back to be at the same level as the background. And this is what doing by affordance. When you look at the component on the interface, the appearance of the component tells you how to interact with it and how to use it. A very important aspect of and the principle of user interface design is the feedback. It refers to the information about the results of user's action when you use the component or the interface element or widget. Is there any feedback from the system telling you that you already have pressed the button or scrolled the scroll bar and so on? If the feedback is there, then you will know that the system has accepted your action and you will wait for a reaction from the system. If you cannot see any clear feedback, that you may use or perform the task of the widget again. Means you may click the button again and again and again because you don't know that your first click was taken by the system. So the feedback is very important. This can be by changing the color of the component or the widget, or changing the appearance of the widget to tell the user that you have taken his action and the system will react soon. More concepts of user interface that we are covering in this chapter is what we call the metaphors. Metaphors means that we are using objects from the user's everyday life. For example, if you look at the screen, you find that the calculator used in this system, basically this is a Windows calculator, very much looks like the real-life calculator that we have in real life, one that we physically use and touch. So to make things easier and avoid users making mistakes, avoid users having difficulties with using your components, try to use the same components or pictures of the same components that they are using in their real life, which means it will be a virtual component, not a physical component. And as users of, for example, Microsoft Office, you will find that they will use a scissors for cut and the folder picture to represent the normal folder in storage system and so on. So when you use the same component that the user are used to use in the real life, you make it easier for them to use these components in your system. And many examples of these components are in Windows operating system, like for example the clock, or even the dialogues and Windows themselves. The central idea behind user interface metaphors is that the designer searches for some relevant pre-existing detailed knowledge, likely to be a mental model common to users. And mental model specific existing knowledge is very helpful for user to use the interface the right way. More examples as we can see here is the calendar that looks like the calendar we use in everyday life, the clock which looks like a watch, okay, and this is clearly helpful and easy for people to know what for these components are and how to deal with them. More components based on interface metaphors are provided in this example. This table will show us more of these examples and relate drawing board to paint application, calculator to calculator application, filling cabinet to file system, and so on. More in metaphors is what we call the direct manipulation, which is a style of interaction based on the metaphor of physical manipulation. People are familiar with the clicking buttons, dragging files from one folder to another for copying, and so on. So direct manipulation confirms and extends the metaphor based on the mental model of people in the real life. And in direct manipulation, the user interface often contains visual representations of some software objects that make up the core system. When the user interacts with these components directly, it will affect the process of the system and may perform the needed tasks. More examples of direct manipulation is given in this slide. Direct manipulation has some benefits, like it's easier for novices who are new to the systems to learn more and quickly. Users will make less errors because they are using a kind of components that they are mentally familiar with. By having a reaction immediately for their actions, users can see if their actions are furthering their goals, and if not, they will change it by doing different things and trying again to get their task completed. Examples of direct manipulation in word processor, for example, is given in this slide. For example, when you try to type anything on your word processor, there will be an instant feedback as you type, and a new text will appear on your screen. It's not only important for you to select what looks like nice widgets. These widgets have some functionalities, so it's also important for you to use the widget that will provide you with the right functionality. Functionality of a widget is defined as the types of tasks the widget enables the user to perform. If you use the what looks like nice widget, and this widget cannot help me as a user to perform my task, then your design is weak design. You should also consider the functionality of the widget, and that widget can help me performing that particular task. Now in the following slides we will discuss some of the widgets functionality and see what kind of tasks they can perform for us. First, we start with the menu bars and menus. This widget provides a way of hierarchically grouping commands. Here is an example of menus and menu bars, and you can see the list of possible selections for functionalities available in this view menu. The menu name suggests what kind of commands you may find in it. For example, file menu will have functionalities on the file, edit menu will have functionalities on the text, and so on. From the HCI perspective, the menu is a reasonably metaphor, familiar one. When you go to a restaurant, you will have a menu that you select from, And here we are giving you a menu of functionalities related to the menu name that you can select from. A very important widget is also the button. It is a button, it's as a widget that can help you taking one single action. That's why they are called action or command buttons. Normally, we choose some good label for the button. As we mentioned earlier, this will increase their visibility because the label of the button will tell you what the button will do, and that's what exactly we mean by visibility. It's also very helpful to have a pop-up textual description of the button. Means when the cursor moved over the button, some small text will appear to tell you what is the functionality of this button, and that will also increase its visibility. More components and widgets. In this slide, we discussed the radio button and checkboxes. These are components that we can use. In case of radio button, we use it to select one choice out of many available choices. Here are examples of these components and how we use checkboxes. In case of checkboxes, you don't have to choose one selection out of many. You may use more than one selection. Very important and basic widget is the window or the screen, which typically gives a view into some aspects of the system or application. Windows have many appearances. In this slide, we show two different types of windows. One important type of windows are dialog boxes, which gives the user information, and also sometimes allow users to enter information. So from the name, it's a dialog. It gives you information and accepts from you information, but at the end, it's a type of windows. Many more widgets and components are available. You can see them in your screens when you use the computer or your smartphone. Some of these famous components are on the lists that allow users to select one piece of information from a list of pieces. A list box, which is a combination of text box and a list. Text field or text areas, which allow users to input text into the system. We have tab pans, labels, sliders, and more components. In this slide, a dialog box is displayed with many widgets and components. We can see radio buttons, text fields, buttons, list boxes, checkboxes, and more components. This is a very good example that can be referred to learn more about the most commonly used and famous graphical user interface widgets. This is the end of Unit 11. More details of user interface design and heuristics will be covered in Unit 12 next. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.